Estamos ya mandando a Camille que arrancamos. Creo que...
Buenas a todos, bienvenidos a un nuevo coloquio de CIMA-DCAO-IFAECI. El día de hoy tenemos a Davide Faranda, que nos viene a visitar, el grupo de él es director investigador de CNRS y trabaja también en LSCE y IPSL. Su trabajo está enfocado en entender y atribuir los eventos extremos al cambio climático usando herramientas estadísticas físicas y también sistemas dinámicos. Ha contribuido en el 7º reporte del IPSL como un autor líder y también coordina la iniciativa internacional ClimaMeter. También es presidente de la división de procesos no lineales de la Unión Europea de Geociencia y es autor o coautor, supongo, de 140 artículos científicos. Ha también creado un videojuego que se llama Climate Strengths y activamente hace divulgación comunicando sobre el cambio climático. Muchas gracias.
Yo también quiero dar unas palabras de bienvenida a Davide en nombre del grupo nuestro en el CIMA que se llama MAD-GEO y bueno, y dentro de IFAECI, gracias, lo tenemos acá en definitiva gracias a que nos salió el proyecto ANR que se llama Templex, y que está consagrado a tratar de desarrollar nuestro enfoque topológico al estudio de la dinámica del clima en diversos aspectos, tanto tenemos papers con el grupo de Martín, estamos trabajando con Marisol, bueno, hay varios involucrados, acá Marco que empieza su doctorado, algunas tesis de licenciatura, y bueno, y con Davide armamos, él es el coordinador de uno de los 5 laboratorios que forman parte de esta ANR. Esos 5 laboratorios son IFAECI, por supuesto, el laboratorio de Sciences du Climat de l'Environnement, donde Gisela estuvo haciendo un año de postdoc junto con Davide. Después tenemos también el laboratorio de meteorología dinámica, del que ahora Davide también es flamante integrante, donde está Sabrina Spike, con quien trabajamos el eje oceanográfico, y también con Michael Lee. Después está el laboratorio Coria, que es un laboratorio que pertenece a la parte del CNRS de ingeniería en la ciudad de Rouen, al norte de Francia. Y después tenemos también Toulouse, con el laboratorio que se llama CECI, donde Caterina estuvo recientemente haciendo una misión de larga duración financiada por el IRD. Así que estamos muy agradecidos todos, no solo a la posibilidad de tenerlo puntualmente a Davide acá, sino a todas las sinergias y las cooperaciones que se están generando gracias a que tuvimos este financiamiento que esperamos derrame un lindo futuro para todos. Bueno, gracias Davide por estar aquí.
Gracias, Denise. Buenas tardes a todos. Bueno, voy a hablar en inglés porque mi nivel de español no es como nivel de presentación científica, pero si quiere hacer una pregunta o algo en español, bueno, vemos cómo hacemos. Espero que la próxima vez pueda hablar completamente en español. Muchas gracias a todo el mundo porque me gusta muchísimo Buenos Aires. Es la primera vez que visito la América del Sur. And I'm gonna switch to English. So yeah, today I'm gonna introduce you a little bit this, let's say, global effort that we are doing to do what we call rapid attribution studies, so to link extreme weather to anthropogenic climate change. And I will not only discuss like specific events. So today I'm going to discuss a little bit more this event that affected Argentina, Bahia Blanca. You can see the images of Reuters, where basically unfortunately, during this event, the road became a lake, not even a river, but a lake. And but I want also to discuss more broadly the implication of climate change and how we do communication, and also the difficulties that we have. I know better the let's say the French side of the game, or the American side of the game, but it's always interesting to do this presentation somewhere else, because well, its challenges can be different, but I think that at the end, if we want to live a better future, we have to find some difficulties and try to understand what's going wrong in our world now. And I think that unfortunately, isolated experience of things that were going wrong without getting too political are spreading in the world. So what before were exceptions of like anti or climate skeptical political behavior, and now are becoming the rules. So let's see what we can do about it, if there is something we can do. And yeah, this presentation, I'm talking on behalf, let's say, as well, you see me, but it's clear that the work that I will present is a team work that is being done by several PhD students, several postdoctoral researchers, and all the fellows like Marisol of the ClimaMeter, that is this international effort that I will present today. And of course, several logos, because when you are from, even here, I see that you have several logos, so you understand, in France it's critical. So if I have to put all the logos, then there is no presentation, basically, there is no space. Okay, so let's start. And yeah, the first attribution that we can make is the attribution of the global temperature. So before going into complicated stuff related to extreme events, I want to show you how much information there is in this figure. How many of you have seen this already? Raise your hand. Okay, so not all. So this is what it's in the AR6, is in the last IPCC report. And basically, it's a curve that shows the historical records of observation of global temperature in terms of anomaly. So fixing the temperature of 8050 as a reference. And then to say that there is a climate change, we have to run simulations, right? The simulation we can run in several ways. We can have just the natural world without introducing greenhouse gases emissions and aerosol. And if we do this, we end up with this green bar, okay, that has this thickness. This is the climate variability for the global temperature, and it's of order 0.1, 0.2 degrees, okay? So then we can do the game by adding only the aerosol, and you see that the aerosol have a cooling effect. So they cool down the planet by, if we add only the aerosol, now we will have minus 0.5 degrees. If we add only the greenhouse gases, we warm the planet by more than the actual warming, that is 1.5 degrees up to 2.5, so it's easy. And if we add all, okay, then we can reproduce the temperature increase, and we have this gray bar. Okay, so now many things are interesting here, because I want to say that I did exactly the same presentation of this plot to the people of the Assemblée Nationale in France, so the people in the parliament. And after I did this, I showed this plot, I asked this question: please raise your hand if you think that climate change is, raise your right hand if you think that climate change is due to human for the 50%, or your left hand if you think that climate change is due to human for 100%. They almost all, they raise the right hand. So they say that climate change is 50% human. But actually, this of course is the wrong answer, because after here, there is no way that you can produce the black line by using green stuff. So it's 100% of climate change that is due to humans. It's clear from here. Okay, so first point is there is some problem in the communication, perhaps of the IPCC. Because in the IPCC we use the wording very likely, it's very likely or extremely likely, and this doesn't translate the fact that in fact is certain, it's something certain, more certain than other things that we have. Now, if you want to see what's going on with the speed of light, apparently our colleagues have discovered that we can go faster if we use space. So we don't have certitude in science, but certain things we can state with a certain level of confidence. And I think here that there is a problem in communicating what we know in terms of climate to the general public, because it's not clear even for our politicians that in this case is 100% minus epsilon if we want this epsilon ridiculously small that we can attribute to human. Then there is another point, and this is more for those working in dynamical system, that is like we hear a lot about geoengineering and the fact that we can cool down the planet if we introduce more aerosol. Okay, so this is basically adding this blue curve to compensate the red curve. Now, any physicist in the room would say, and any physicist in the universe would say that it's a bad choice to compensate something diverging with another divergence, right? It's like this rope game where you put more people on one side and more people on the other side. And you have only two options when you do these things. Either you create such big instability that at a certain point someone falls, or you can break the rope. Okay? So for any physicist, this geoengineering based on aerosol, it's simply not a solution of the problem. Like you don't cure a divergence with another divergence. Never. Okay, you try to stabilize the process, but not to add another one that adds more instability. So that's the first thing that we learned with this game, and also we did the first attribution. Okay, so the other thing is that how these these small temperature variation translate in something that actually we care. No, because there is this thing that like yesterday, the temperature in Buenos Aires during the day was 28, 29 degrees, and in the night was 10, 11, was quite chilly. So 20 degrees in one day, why we should care of this 1.5 degrees? Because actually what matters is the increment with respect to the typical temperature of the planet, exactly like the fever. So in the fever, our body operates at 36 degrees. When we add 1, 2, 3, 4 degrees more, we get symptoms, okay? And these symptoms in the climate system are extreme events. So in the IPCC, there is this nice plot that shows how the temperature extreme scale when the global temperature goes up to 4 degrees, how the moisture change when the temperature goes up, and how the precipitation change when we go up. And bad news, also if you focus here on South America, you see that first of all, the temperature extremes go larger, they have larger values than the global temperature. So even if we have 2 degrees warming, we can have heat waves that are 4 or 5 degrees warmer with respect to the previous climate. It's non-linear. Then we have another point that is in some areas getting wetter, in some areas it's getting drier. But we have lots of area with vegetation and agriculture that are getting drier. So that's bad news. And also, over land, almost all the extremes of precipitation, there are, I discussed with Diana and Victoria about this, but they are increasing, okay? So there is a diverging world. We are not just going to adapt to a warmer world full stop. This maybe we can do, but the thing is we should adapt to a world where we have warmer, drier, wetter, all at the same time. It's like a crazy world, and for which things can go in many different directions. So you can build an infrastructure to sustain more rain, but if at a certain point you have no rain, so what you have to do? So this is the complication with extreme weather. And now going to the extreme events attribution. and because it's lunchtime, we will go to some cuisine class, okay? So doing extreme events attribution is like cooking a cake. And I will move this somewhere else. Yeah, over the CNRS logo, I will not be happy. So the idea is that when we do extreme events attribution, we want to understand whether an event has been affected by greenhouse gases emissions, okay? So the example I do, it's like, imagine that your extreme event, for example, an heat wave, is a cake. And Denise is a very good friend of mine. She offers me a cake, okay? A chocolate cake, because I like chocolate cake. But then in this cake, she leaves. So I don't know what is inside the cake, but I cannot eat butter, okay? So is there butter in the cake or not? Butter is like climate change. So how we can determine if in a cake there is butter or not? We have two possibilities. One possibility is that Denise is a good friend of mine, so she offered me several cakes back in the past. So I can compare if I have records of the cake pictures, the cake that she just offered me with all the previous one, and see if it's at certain point something changed. So I can use historical data of extreme events that are similar to the one that I want to attribute to determine if there is some change. Or otherwise, I can use climate models, my kitchen, to reproduce several times the cake with and without butter and compare it to the one of the needs. Okay, so these two approach can both fail for several reasons. First of all, the butter is not the only ingredient in the cake. There is chocolate, so the quality of the chocolate will determine how the cake is together with other ingredients, sugar, eggs, or whatever. So I have to isolate only this ingredient. And in the climate, it's the same. I can have an extreme event because there is El Niño, La Niña, you know, so there are different things that can go wrong. Then there is another point. The kitchen is not the same. The climate model that I'm using, if I'm using this option, is not the same kitchen that Denise used to produce the cake. And we know when we change the oven, the first cakes that we made with the new kitchen are not good. Almost, you know, even if the oven is super, no, we just have to get used. And then there is another point here that I didn't mention. Let's see if you find what is the other source of error. So my colleague here can be a source of error. So our own interpretation of the attribution study can introduce, because if we are climate scientists, perhaps we have the tendency of saying, yes, it's climate change. If we work for Total or Eni, to say the French and the Italian, maybe you have interest to say, no, there is not climate change. Okay, so the influence of who is analyzing the attribution study is also important. That's attribution. So now how we can make this useful? But first of all, what we can attribute and what we cannot. This plot, sorry if I will say what is in the bold, so I see that you struggle, but is how well we understand the influence of extreme events in general on the climate versus how the ability to attribute a single event. So first of all, this is a lower triangular. Okay, so we know better the statistics of all events than to attribute a single one. Okay, that's not surprising, right? But then what we can attribute well? Extreme cold and extreme heat, because this is linked directly to the global temperature, right? So we expect less cold and more heat. Very nice. And in fact, the first attribution studies were exactly focusing on heat wave or cold spell, okay? And then what is already a little bit more difficult is drought. Why drought is more difficult?
That's true, like temperature and precipitation.
Yes, because there is more than one variable involved. Let's say that this is the first thing, and also the scale is difficult to define. is dry for 3 months, 6 months, 1 year, 2 years. And since it's a long event, we have less data. And then the other events that are here are all events linked to extreme precipitation or wildfires that are events occurring at small scale and with a non-continuous structure. So, as we were discussing before with Victoria, so when you have a severe storm, maybe things can happen 10 kilometers apart, you have the storm, you don't have it, okay? So today, perhaps some area of Buenos Aires will have extreme rain and some other few drops. Okay?
You may also have like a different perception from different point of view, not for the agronomists or the
Yes, there is also this. Exactly. When we go to something that is related, for example, to floods, then we have to decide if we want to focus on rain or we want to focus on the rivers. And so we have the problem also of deciding the observable. This graph is from the 2016 and it's produced by the NOAA, rest in peace a little bit. And now it's still valid in some sense, except that things are shifting a bit up. Okay, so we know better it ways, but actually what the research that we focus on now in my team in Saclay and the PhD student I have, it's one for each of the poles, let's say, that is trying somehow to fill the gap in attribution for the next IPCC report. But one thing is clear now, that is climate change is affecting all extreme events, okay? Because it's the same as a theater play. Okay, so when you go to theater, you see a show and you see the actors moving. Imagine that the actors are the extreme events. They move on a scenario, okay, and you see the play. Now imagine that you put on the scene olive oil or butter, since we have this, on the floor. When you add a little bit of butter, some actor will start to sleep, no? But when you have a lot of butter, all the actors will be affected by the fact that there is butter on the scene. So if we change the scenario, the background, the climate, all the things that move in the climate are affected by climate change. So that's the philosophy that we use in ClimaMeter, is not to understand only if events are affected, but we know that they are affected, so we have to quantify how much. Okay, and how much is what it matters then to do the adaptation. Is this heat wave 4, 5, 6, 10, 20 degrees warmer because of climate change? Okay, so and how you expect this on some area? So that's what we do now. And to do this, we have developed ClimaMeter that is at the same time a methodology to perform this attribution to climate change or extreme events, but also a group of colleagues, and I was mentioning Marisol is involved. We are all over the world, and we are like sentinels of extreme weather events that can happen anywhere and that have produced impacts, because we're not going to attribute something that is here. I'm sorry if there is some islands that I don't know where, but if there is nothing at stake, or no one more than nothing, okay, we are not, it's not something that we would like to attribute. So there are events that are interesting for the meteorologists, like the cyclone developing here or whatever, but for us it's not interesting unless they actually affect someone or something, okay, that we care of. Okay, and there is some events that is kind of clear that we have to do attribution if we are in this consortium. For example, this Bahia Blanca floods I will discuss. It's an event that is clear. It has so much impact on the population that we will cover. And some other, of course, less impact, but can be interesting for us to cover. So the way we work, to give you an idea of what this is, every time that there is an event, we are on a Slack group, and in this Slack group, we decide whether we cover it or not. And then what happens is that I run the analysis, I will explain you how, on my laptop, on this laptop, because it's also a, let's say, sober attribution technique that doesn't require models. And then we open a document, a shared document, where we write the report, we write a press release, and we communicate to the general public. We put it online, okay? So that's how we work. And we are very rapid in some sense, because the event happens, and in 24 to 48 hours, we publish something. Sometimes a bit slower, but normally we try to be on the event or just immediately after. This is why, because we can add some numbers, even if it's a rapid analysis, we can add some numbers to things that are happening now. So we can be in the discussion with the media and saying like, look, this is not just like God being angry with us, or Poseidon, or whatever is your pantheon. But no, it's happening because of us, because of our greenhouse gases emissions. And with some numbers, okay? So what people are experiencing, which severity. So that's what we do. And this is what we have covered. And as you can see, there is it's Europe-centric a little bit and US-centric, in the sense that since we are a lot focusing based on Europe, we tend to cover more things that happen in Europe. But actually, with the last studies, we have moved more towards covering Southeast Asia, and also now, thanks to Marisol and other colleagues that we have in Colombia, we are covering a little bit more the South America, okay? So that's what we do, and the kind of output that we get is for different event types. So this blue is rain events, then we have a windstorm, including tropical cyclone, then we have heat wave in yellow, we have fires in red, wildfires, and we have cold spell, little bit, there are not many, in violet. Okay, so that's what we cover, and then what we can see, even if you cannot read it, I will say. So what the source of detected change is, okay? So we have from influenced by the natural variability to mostly strengthened by climate change. And as you can see, with the except of 3 events for which we have only natural variability, the rest, it's all at least, there is a signature, cannot be explained only by natural variability, okay? So almost all the events that we have covered are influenced by climate change. Then there is another diagnostic that we can make, is how rare is the event? Is it something new? Is it something typical in the weather that we expect? And so you can see here that from rare to very exceptional, because by definition all the events that we cover are at least rare, we have that at least, well, 1/3 of the events are very exceptional, in the sense that we don't have other references in the data that look like this one. When we have this case, we publish the study with low confidence, because the cake is unique, so we don't have much to compare with, okay? So that's how we proceed. The rarity gives us the scale for the confidence. Okay, so this, it's a bit a strange way of doing presentations, where first I spoil the results and then I tell you the story. But basically, the way we do attribution is that we have this chain that is always there. So I remember that we have impacts. If we don't have impacts, we don't do attribution study. So for example, the impact can be multiple, like in Bahia Blanca floods, everything was affected, right? So health, of course, infrastructure, property, tourism, agriculture, and all the other things that you can think. Then we have to see what is the hazard producing the impacts. In that case, it was rain, okay? But then if you stop at this level and you try to just see if the rain has changed with present, like in the present climate with respect to a climate without CO2 emissions, then you cannot get the sense of what is changing, because rain can be produced by thunderstorm or can be produced by large scale, for example, extratropical cyclone, and here in Argentina is exactly like this. So you can have large scale storm or localized thunderstorm, and you have to distinguish, you have to go to the level of the weather phenomena. So you have to track the weather pattern that are responsible for the events. So if we are at this level, we can make what we call conditional attribution. That is like we're not just doing statistics and try to understand how rain is changing, but we are doing these statistics conditioned to the phenomenon that is producing the weather, the extreme hazard. Okay, and at this level we have to separate between greenhouse gases emissions and climate variability. This is clear. So with the example will be more clear. So what we do in practice is that we look for analogs of the weather map associated with the extreme events. Okay, so analogs are similar maps. So they are defined, this comes in, here is the connection with what Denise and the colleagues in dynamical system are doing. I did a PhD thesis in dynamical system, where actually the idea was to define extreme events as recurrences of rare states, okay? So if you have something rare, is extreme. This is what we experience also, right? If the weather is normal, we have it every day, it's not extreme. But if it's rare, then there is something that is potentially extreme, okay? So how we do practically these things? So we look at the weather map that is producing our hazard. So this little map here, I'm sorry that the screen is not that big, is the pressure anomaly. Okay, so it's a map of pressure during the 7 March 2025. It is the date of the Bahia Blanca floods. Then what we can do is to take this map and look for similar maps in 2 periods. The past period, that is 1950-1986 for us, because the data, ERA 5 data that we use start in 1950, okay, and compare the situation that we find in this first period to the one in the present climate, 1987-2023 for the moment. Then
with simulations, no, with
the data, with the observation. Yeah. So basically, what we do, I don't know if there is.
No, I think that's
okay, but yeah, I mean, I will just repeat the same things, but it's this. So we look for similar events, and we fix the number of similar events in past and present period. So we end up with the best 20 analogs in the past and best 20 in the present. Then what we can do is present minus past, okay, and see if something has changed, okay? So in this case, let me, before telling you the result, let me explain all the first row. So this is what happens the 7th March 2015 in terms of pressure, temperature, precipitation, and wind. So here what you can see is that we have this low pressure structure, actually two, one to the south and one to the north of Bahia Blanca. Then we have temperature anomalies where in the river basin of Bahia Blanca, basically we have colder temperature because it was cooling by the rain. Okay, and then we have these huge effects for the how we use it then. And this is the precipitation data that shows you that actually the event was also very severe because it rained exactly on the river basin. So all the water was filling the river basin. Marisol, correct me if I'm wrong, or if you want to add something, because I have taken it from, okay. And so basically what you see is that this is for the weather. Then, as I was saying, we have this, so imagine that we have our time, so we can construct the time series of the distances between this map and all the other maps in the past in this region. Okay, so this will look something like this. Okay, and then what we do to look for the analogs is that we separate. Here, this time is 1950. These are daily values. Then we have 1986, and here we have 2023. So to look for the analog situation, what we do, we take the minima of the distances from this map and all the other maps in this region in the time. So for example, here there is this, and imagine these are 2, 4, 6. Okay, then in the present period I take also 6. In reality they are more. There is some condition. Okay, and then what I have for this is the map in that region of everything. Sea level pressure, temperature, precipitation, wind. Okay, so I can do present minus past and see if there is some change. So in this case, what we have is that the pressure didn't change much, because even if you cannot see the graph here, it's 0.2 hectopascal, which is basically nothing. The temperature just a little bit. Precipitation, we have some increase, but scattered. Okay, and then we have wind speed changes that are models. But we do see increase in precipitation that is significant in some area that was affected by the flood. So the report that we wrote was indeed that the floods in Bahia Blanca were affected by climate change, and that we had 7% localized weather conditions, okay, that we have exceptional meteorological conditions, that is this indicator that quantify how good are the analogs, okay, told us that in fact the analogs were not so good, so that this condition is exceptional. This is also information that we give. And then we have to make the attribution, okay? The attribution, we have to exclude the variability, okay? So how do we do these things of the variability? We can look if other things in the climate could have influenced the event. For example, El Niño, La Niña, or the phases of the Atlantic and the Pacific oscillations, okay? So since we have the dates of the analogs in the past and in the present period, we can compute the values of the indices like ENSO, PDO, AMO, the indices of the variability. And we can see if there is a shift between the analogs of the past and the analogs of the present in the phase of the indices, okay? Because if there is a shift, for example, in the past, these were associated with La Niña, and now these are associated with El Niño, I cannot exclude that there is a role of this mode of variability in the way the event is observed, okay? So in this case, only one of the modes was that we have analyzed was shifting, and the other that we analyzed not. So the bar of this indicator that goes from influence to natural variability to strengthened by climate change was 2/3. Okay, so now I have a PhD student, Clara, who is working at making this bar continuous with more rigorous tests. And yeah, so since we can compute this, we can make the last statement, that is, we must describe the increased precipitation in March 2025 Argentina floods to human-driven climate change, and natural climate variability likely played a modest role. Okay, so that was our conclusion. And this is what has gone in the report. And then Marisol communicated a lot about this. And this is the list of the things that came up. And yes, we have a television, like the C5N, La Nación, Infobae, La Gaceta, El Diario R, La Izquierda Diario, Tiempo Argentino, Economia Sostenibile. So we have general media and media that are more specific to the environment. but there was a lot of coverage, and I remember that Marisol, you were everywhere in that time, which was good because actually also seeing like the general orientation of the actual government with respect to the climate change, it's good that we could be in the discussion and get some coverage. This was very interesting that in Argentina we had such a good coverage despite the orientation of the government, and it's similar to what happened in Italy with the government of Giorgia Meloni, where we still, when we do a ClimaMeter study, we still publish, we are interviewed, we can go to the RAI television, the national television, and there is actually not opposition. This is very different, for example, from what our colleagues in the US are experiencing, where they are not allowed to discuss the attribution studies. And at the point that I had to convene a session on attribution in the HU because none of our colleagues was able to do so. So there are differences in the way each country can express with respect to this topic.
Is this a regulation?
No, it's not. In fact, we don't know why. So this is something that I'm posing there. But you know, in the case of Italy, for example, we can still discuss this in the media without many problems. In other countries, not the same. So that's interesting. And it's to say that this is basically, I will finish on this, that I think that still we may think that things are not possible in the current world and that we are just at the level that we are shut up. But in fact, it's not like this. And we still have, we can still have some range of action. Where these studies continues to exist and they continue to inform the population, and the local stakeholders, they are interested in having information, even if they are from the part that is skeptical or whatever. They need this to reconstruct, rebuild, because if you know that the event is becoming more severe and you are the mayor of Bahia Blanca, you can be from any party you want. At the end, the citizen will come at your door and say, like, what's going on, right? So this means that we can still have our range of action, and we can still be there to make this transition happen in some sense, or at least inform the citizen. So now, what's next, right? The next is that I think that there is something that for sure we are. So, in fact, one thing that is important is this. I don't know if Marisol and you agree. We don't have about communication of climate change. We don't have the counterfactual war. What would have happened if the IPCC didn't exist, for example? If perhaps things would be even worse than now. Okay, so we cannot be too harsh on ourselves and say like we didn't communicate well, whatever, and so on and so forth. But one thing that we can do, and especially I think where you, the younger generation, can contribute, is it's the time to embark, no, all our colleagues and friends and citizens, whatever, at all the scale that we are, in something that is not just gray and dark and negative, but say like really, okay, we have the world is going towards this constraint, is going towards this warming. We see already the effect, and now is the question how we can live still in Bahia Blanca, Buenos Aires, Cordoba, wherever you want, with the constraint that climate change poses, okay, and try to reduce the impact as much as we can, right? So make this like something that happens now, not something just that is gray and black and there is no future. No, because we know that it's not like this. Okay, so it's an angle of action. Then I think that the other angle of action is that we have to change a little bit the language. No, my feeling is that in the IPCC there are too many scenarios, and some of these scenarios are sci-fi. science fiction, ficciones, no? Like, really, but they were not. So is it? I pose it as a question. It's like this end of the talk is a bit blah blah blah. I know, but it's like, is it really useful to have all these scenarios when we know that one or two can happen in reality? Because if we fix the scenario, then we know what we have to do to adapt to. And if we fix a good and only two scenarios, we can have some reference of things that we can do and how we can live with climate change, and things that we will not be able to do, and we will know what we will lose, okay, in that scenario. Okay, so for example, if we take the current scenario, the airport, the current warming, and we extrapolate the airport of Nice in France, it's underwater. There is no, the sea level it's underwater. And so, like these, also other things like New York. So if instead of presenting 5 scenarios in which in 2 the airport of Nice survive, in the other 3, we say like, there is this one, Nice is underwater. Then we can start the discussion. Do we want to save, or we are okay to lose it? Because if we want to save it, then we have to reduce the CO2 emissions. But if we start with 5, 6 scenarios, where is the discussion? So I think that this can be a point. And then, of course, there is this thing that if we don't, so we have to really see who is more vulnerable to climate change, right? So this is to stop these things that at the end, what we see now is the counter reaction of privileged countries like the US, for example, I'm not afraid of saying it, that to keep their privilege they had for centuries, they want to impose some unethical solution for this problem. No, this is where we don't want to live in this world where someone imposes the solution that is based again on neocolonialism, ultraliberalism, to all the other countries. I think this is not acceptable, the benefit of 1,000 people in one country against the wealth of 9 billion people all over the world. So I think if we start from this, we have elements to advance, and let's see what happens. But this is, I think, something that, of course, from the point of view of scientists, we can, we have a role to play. We just have to be brave enough to still playing it with all the constraints that we have in our everyday life. Okay, and with this, let's go back to science. I want to show you these 2 references, and of course, ClimaMeter, as you have understood, is an open family. So in case you are interested in joining and support us, it's definitely something that we will really appreciate. And of course, if we can do science still in this way, it is open and talk to each other, is thanks to the institutions that support us, and this we don't have to forget. And I think the CNRS is in this moment is doing a great job, honestly, in giving us the freedom to be here and say what we want and being covered for this. So thank you very much. Muchas gracias for that.
A local question for the France, for France politics. Is there in the near future someone similar to Trump in terms of the climate denial that could come?
Yes, I mean, the thing is, the way I see it is that at the end, so now I really have to go in the political. So I think that it's not even about politics, it's about the system we are living in that is shifting from something liberal, that's something that is the next stage of the liberalism, that is like monopolism at the end in some sense. So we have a bunch in France, what is happening, not being very global, is that there is a bunch of very rich people that are basically handling the most quoted society in the stock market that want to make more profit. So at a certain point, when there was this Paris Agreement in the COP in 2015, right? Some of these people understood that they would make profit on renewable energy, green transition, and for some years it went in that direction, right? So we start to make this green transition, solar panels, and so on and so forth. Now there is some shift because it means that not all these people can make money out of it. They see other opportunities to make money. Wars, for example. So there was an article in Le Monde that is not the Le Monde is a journal from the moderate that was saying it's very good. The gross product of France is increasing again thanks to selling planes and war armies and weapons. And I was like, okay, good news. Is it a good news or not? No? But at the end, my vision is that for some, a bit like health, unfortunately, health should be a concern and the right of all human beings, like the right to have water, to live in a country that is not polluted, to have a climate that is stable. But someone is making money out of health. Someone is not interested in healing all the disease. Someone is interested in selling products. So the way I see it is that climate change has become like health, a business, and there are interests, opposite interests, and we have to move back from this to the level where it's a human right to live in a climate that is stable. And it's only if we make this shift we will be able to move forward. Otherwise, it's not about the extreme right or some political parties. It's about, is it a human right, and it's something that all the parties have to acknowledge as important, or it's something where we can make profit out of it?
Yeah, I have a question. I'm quite officially against the attribution side of the science, because I don't see the point. In fact, if already politicians doesn't believe on climate change, it's not because the science didn't show it enough. It's because they don't want to believe in it.
Yeah, so they believe in climate change, but their interests are directed somewhere else.
I don't see why attribution studies will change that. And how attribution studies will increase the willingness of the politicians for the adaptation and reduction of risk of impact.
Yeah, so I take your point. Honestly, as I said before at the end of the talk, I said that we don't have the counterfactual world where attribution studies didn't exist at all. So I don't know what would have happened if we didn't communicate like the way we did. But there is at least the motivation to do it is that there is a large part. So we have a polarization where people who believe in climate change, people who say don't believe in climate change, and then we have also in the politicians, we have this. But in the middle of this cake, there are also people that are waiting for some information to come for them to take a direction. And I think it's on these people that are in between at all the level of the stakeholder, the level of the level of the citizen when we do mass media communication and so on, that we can act when we make attribution studies. In France, that's, I said it also for Bahia Blanca before, but in France, our best customers are major of the cities because they see the problem. We are all attached to our hometown, right? If you're the mayor of your city, you see that your city is destroyed by the floodings, no? Then you say like, what's going on? So they come to us and they say like, yeah, it's happening, we see it. So I think that the basis of these people, it's already convinced, and it's there that they have the connection with the citizen. So there is definitely something that we can do, and at a certain point, this problem will be so evident that cities like New York, for example, will have to deal with this every single day. So it's a matter of time. I repeat, I think the problem is then how to make this turning point with the level, this level of this bunch of people that unfortunately control the media, control the social media, and others, and move a lot of money, and that can decide to make the transition happen or not. So for me, that's the thing. And yes, I agree that these people were not going to convince them with attribution studies, because they take the attribution studies, they see what is happening and say like, okay, this is happening, can we make more profits before this becomes too bad? And how? And on the shoulder of which people? So I think that this is what we are dealing now.
And where should I live in order to survive for longer?
So I was thinking of doing a comment, and then I will do a comment and a question. So there is at the same time as you have these politicians denying climate change, there is in the political realm, there have been many advances. For example, in Argentina, with the reform of the province constitutions, the provincial constitutions, many have included the inclusion of climate as an issue. And so this opens the key for making for law enforcement for complying with some climate safe standards. Let's put it in that. So with some minimum environmental conditions that the government needs to is obliged to fulfill. And so there are in the legal system, it's ready now to ask for to governments or private individuals to comply with this requirement. And so the question is that if you see people asking for a proof, or if you have already received people asking proof on ClimaMeter up to attribute climate change for the legal system. So the question is if they are asking you for evidence for legal purposes.
Yes, thanks for this, because I think it's a point that I should have said at a certain point, that the other instrument that we have is, of course, the other power, that is the legal power at the national and international level. And this is also the framework of the agreements that are made at COP, for example, like now in Brazil. So this is another level. And I think that when it's in the law, it's more difficult to take it out. This is the same for the rights of the people. Yeah, so yes, and we have been asked to participate in climate mitigation studies. And there are also sentences of the International Court of Justice, the European Court of Justice, to sanction the state like France or Switzerland that are not respecting the Paris Agreement, and so they are affecting the health of the people. So this, of course, is an important way to go, and it was a very good way to go until, unfortunately, some guy was elected, and then he decided that the United Nations was just toilet paper. And at the end, I think that, again, the world is not properties of exclusive individuals. So if we all join and restore what we have achieved with 70 years of diplomacy after the World War II, and we keep it as guideline, we can just progress as the world was doing, and we will not go back. So we have to hold on, and that's why we're still there, making the studies, supporting our colleagues that are in trouble, for example, in the US, and making the study also for them. So that's what we can do, and we can hope that this parenthesis ends, and we move to the real problems of humanity, like climate change.
Totalmente, estamos sin tiempo. ¿Cuántos días va a costar
hasta el martes. Entonces, sí,
Porque si no era.
pero voy a volver. Muchas gracias.
Aplausos. Jueves 12 de diciembre, donde vamos a tener coloquios sobre la campaña Falcor liderada por